In this demonstration, we will show how easy it is to create PCB circuits in TINA. We will use a battery, a resistor, a switch, and 2 LEDs. Let's first place a battery on the editing screen. We change its voltage to 3 volts. A footprint is automatically associated with each component. We click on the footprint line and see that a small battery symbol has already been assigned. If the battery was external, we could use a connector instead. In this case, we will use the default battery symbol. Because we do not want to make any changes, we click Cancel. Click OK to confirm the change to the voltage. Now we add the next component, a resistor. We change the resistance value to 68 ohms. It is possible to change the footprint for the resistor as well, to symbols of various lengths or SMD. In this case, we use the default and click OK. We also approve the 68 ohm resistance value. Next, we add a switch. Click on the Switches tab and select the alternate switch from the Switches toolbar. We first rotate the switch by 180 degrees, then place it. Lastly, we add 2 LEDs. Click on the Semiconductors tab, select an LED from the toolbar, rotate it by 90 degrees and place it on the schematic. This is by default a red LED. We will make the second LED of another color. First, we place the LED and double-click on it. We click on the button in the Type line, and we see that it is a red LED. We can now choose from several different types, each with a different color. We choose the second on the list, which will be green, and click OK. Note that the footprint in this case follows from the component part number and is automatically assigned. Press OK, and the green LED appears on the screen. All that is left is to connect the components with wire. We do this in the standard way. We click on the first point, trace the wire's path with the mouse, and click again at the end point. Next, we connect the remaining terminals. We connect the lower part of the switch to the red LED and the higher part to the green. We connect the ground by clicking on the diodes. Now the circuit is complete. We can test it interactively by clicking the DC Interactive Mode button. We see that the red LED lights up immediately. If we click on the switch, the green lights up as well. We can also see realistic representations of the components used in the simulation by clicking on the 2D, 3D view switch. Of course, we can also test the circuit operations with these components. Finally, we switch back to the standard schematic symbols. Next, we will create a PCB from this circuit. First, click the PCB design icon. In the dialog, we can choose to modify an existing project or start a new project. In this case, we do the latter. We note that auto placement is already selected. We will complete auto routing later once the components are in place. Tina includes a number of board templates which we may use in our designs. We will be creating a single-sided, one-layer PCB, so we choose the first option. Note that it is possible to create more complicated two-sided, multi-layer PCBs using the appropriate templates. The board dimensions may be customized. In this example, we will use the default settings. Click OK, and the components are placed automatically. Before auto-routing, the components most often need to be rearranged. Use the mouse and the rotate icons to move the components to their desired positions. Next, select the auto-routing command from the Tools menu. Or press Ctrl F5 and the components are routed. To see the PCB in 3D, click on the 3D View button. By switching to Tina's schematic editor screen, we can also see the schematic diagram of the circuit. We can now test the circuit, either on the schematic or using the switch on the 3D view. Note that in 3D view, it is also possible to see the routing on the bottom of the board. To do this, hold down the left mouse button and tilt the board to see the underside. Here we have shown how to create a single-sided PCB in Tina. In the following section, we will show how to make a double-sided PCB. To turn the design from the previous section into a double-sided PCB, we need only to change the layer settings. Choose Layer from the Options menu. We see that the top layer of the PCB is currently unused. If we change it to a routing layer, the auto router will use both the top and the bottom layers. Click OK to approve the layer settings. Select Auto Route from the Tools menu or press Ctrl F5. We see that now 2 wires have been placed on top of the board. To see the changes in 3D, click the 3D View button. Now, on the top of the board, we see one wire running from the LED to the battery, and another between the resistor and the battery. Tilt the PCB to view the routing on the bottom of the board. We tilt the board back and click on the switch to test it. This concludes our demonstration of creating single and double-sided PCBs in Tina.